Okay, so this is question 8 of June 2011, Pure Mathematics, Paper 1, Variant 2. This is question 8, part 2. In the last lecture, we did question 8, part 1. Now, please have the question in front of you. We know that OA is equal to 2, 3, 5. We know that OB is equal to 4, 2, 3. And we know that OC is equal to 10, 0, 6. And we were asked in the first problem to find angle ABC. We know that this as 112.4. Surprisingly so, we don't need this in this problem. So how do we find the position vector OD? Where ABCD is a parallelogram. Now let's just draw this. I'm going to draw it in 2D. So we have A, we have, I'll draw this in separate colors. We have B, we have C. Now if we just draw this, and then we have another vector, draw this in green. This is D. And this OD is what we have to find over here. This OD position vector. Sorry, it's too blunt. Now let me make this full screen and let's get to it. Now how do we find OA? According to the diagram we made, we can use the addition of vectors to our advantage. Now in the addition method of vectors, we know a method called tail to tip. I hope you guys heard of this. Tail to tip method is the key thing. Sorry, hold on. I'll just clear the screen and write it again. We've heard something called a tail to tip. I hope you guys heard of this method. If you haven't, I'll explain it to you very briefly. Now, suppose you have one vector and you have another vector. And one vector is going this way. As you know, a vector consists of a magnitude, I'll just write it as mag, and a direction. I'll write this as dir. And if you have two vectors, one going in this direction, denoted by the arrow, and the other going in this direction, since this is going from its tail is behind the arrow. This is the tail for this. This is the tail for this vector, and the tip is in front of the arrow. This is the tip for this vector. And for this vector, I'll just change the color. This is the tail for this vector, and this is the tip for this vector. So, and this is the tail for this vector and tip for this vector. Now you can see that they share a tip. Now, since it's going from the tip of one vector to the tail of the other, we go from tail to tip, tip to tail. Sorry, tail to tip and tail to tip of two vectors. We know that the final resultant vector, that is adding these two vectors, is from the tail of one vector to the tip of the other vector. So if we do the tail from one vector to the tip of the other vector, we get this. And its direction is here because it's from the tail to the tip. Now, reproducing this material over here, I hope you understood that. If you have not, please review tail to tip method. Now, reproducing that material over here, let me change the color. We can say that in our diagram over here, our OA is traveling this way and our AD is traveling this way. So we can automatically say OD, our position vector of D, is equal to OA plus O plus AD. Sorry. Now, how do we get that? So, since it's going from the tail of this vector to the tip of this vector, and this is going from the tail of AD to the tip of AD, we know that our resultant is from the tail of OA to the tip of AD. That is the tail of one vector to the tip of the other vector. So it'll become OD automatically. Now let's solve this. We know that OD is equal to OA plus BC. How do we get this? We already know that this is a parallelogram. Over here, this is a parallelogram. Now, in a parallelogram, the two opposite sides have same magnitude and same direction. So, reproducing that over here, let me just clear the page. Let's clear this page. I hope you've taken it down. We know that OD is equal to OA plus BC. And how do we do this? So we know that OA, we automatically know, is 2, 3, 5. BC we can find out using our subtraction method of vectors. We take the second letter C and we say OC minus, we take the first letter minus OB and use the position vectors of them. That is OC and OB. And this is equal to, let's solve this, OC minus OB is 6 minus 2 and 3. So, continuing this, we can say finally that we know BC now, and we know OA. So we know that OD will equal to OA plus BC. So what is OA plus BC? I'll just do it on the spot. I don't need to. I think you understand the adding of components by now. So 2 plus 6, 8. 3 minus 2, 1, and 5 plus 3, 8. 8, 1, 8, which is our final answer. So this is our final answer for position vector OD. I hope you understood this lecture. If you haven't, please email me. Or, yeah, email is the best way. I have my email on my YouTube.